Welcome back, everyone. In this lesson, we are going to take a look at another fairly large data set of tens of thousands of records that relate to the housing crash of 2008-2009. We're going to take a look at the housing prices prior and the housing prices afterwards within the entire United States. And we're also going to take a look at some more specific, how to pull out a particular metropolitan area. We're going to focus on the Washington, D.C. metro area. So let's go ahead and get started. First and foremost, I'm going to create a brand new Python 3 notebook. I'm going to name this one 024 Homes. It's worthwhile seeing the data set, so let me bring it up so you can see the actual data set. And this is part of it. As you can see, there are lots of, thousands of rows here, and we have over 260, I think 262 columns. I'm not quite sure what the region name is. Might be something that the government uses, but not the region name, the region ID. I mean, the region name is the zip code, and we have the city, state, and the metropolitan area. And we have the size rank, which refers to the population size, with the most populous being Queens, New York, obviously. Then we have the year followed by a two-digit month, and the numbers that you see here are the prices of the homes per square foot. And you can see that some of the data is in fact missing. As we move forward, we get more data for a lot of these places. They start around end of 2003. So with that in mind, let's go ahead and get started and read in the data. We're going to put in some comments here first and foremost. Reading in data about homes. I'm going to import some libraries, as you might expect. Pandas as PD, so we can just call it PD instead of typing pandas all the time. Let's bring in matplotlib.pyplot for plotting as PLT. We're going to import the OS module so we can work with the files if we need to. And we're also going to bring in this thing called warnings. Let me leave it like that for now, and then I'll come back to it. Let me do a Shift-Enter to make sure that everything was imported properly. Oops, we got a problem. I probably misspelled something here. Pyplot. There we go. So let's take a look at that. And what's going on over here? Warnings. So my spelling is this morning not too great. Let's keep going. I am going to put in some custom settings for pandas to make the output larger. You might recall from some of the previous videos when you have a data frame put out its information that at some point it shows ... and it doesn't show everything because you can't fit it all on the screen. So what we're doing is we're basically telling pandas, well, I want to see a lot more on this screen before you put your ... etc. So let's call the set option method over here, and we're going to go to the display and get the max rows property and set this to 6,000. So it's going to show 6,000 rows before we get to ... pd.set option. Again, display, but this time we want to take a look at max columns. And we're going to ask that it will show us 300 columns. We only have 262, so this is more than enough. And we're going to have set option, again, display dot width. We're going to make it be 150. I believe 80 is the default. Let's do Shift-Enter, and everything is fine. Let's go down and load the data. So I'm going to create a data variable and call it data variable, and do pd.read_csv. So read the CSV file, and it is called zip.csv. It's in the same directory, so I can just call it that. And the separator is going to be a comma. And let's take a look at data.head once the data frame has been created. And here we are. We can see, whoops, I forgot my parentheses. I was wondering why I was showing it this way. So as you can see, we see the first 5 rows, and it read in the information and created our data frame for us. Notice that where there is no data, it puts in NaN for not a number. Good, let's keep going. Let's take a look at the columns. So I can say data.columns.values. And we can see that we have lots of columns: region ID, region name, city, state, metro, and then we have all the years and months. If I wanted to see what this data set looks like, I can call data.shape. Let's do that. And it tells us there are 12,777 rows and 246 columns. I thought there were 262, but apparently it's 246. Let's go ahead and check the top 10 values in the metro column. So we can see that there is a metro column here. Let's check that out. We're going to take the data frame that we just created data. We're going to go for metro. So we're going to slice out metro, and we want to just get the first 10. And remember, when you don't put an initial value, it assumes you're starting at 0. And always remember that the last index is not included. So it's the first index is included, but the last index is not. So there we have 10 values. New York, as you can see, 1, 2, 3, 4, 5 of them are New York. 1 El Paso, 1 Chicago, the other 3 are in Los Angeles. So what I'd like to do now is to focus on the DC metro area. Let's create a new data frame, call it DC Metro DF for data frame. And we're going to take our existing data frame data and locate this metro region and double equality Washington. So we're looking for, remember the double equality is a comparison. So we're saying look for all metros that are Washington, locate them, and create this new data frame. And let's take a look at DC Metro df.head. And here we are. Interestingly enough, the first one that shows up is the number 114. Well, it's really 115 because it's 0-based. But you can see it's Woodbridge, Virginia, which is a part of the Washington metro area in Prince William County. And size rank is, in fact, 115. So we have that. That's great. Let's take a look at the shape of this data. So DC dot shape. And we have, well, that's what I was thinking, 262. 262 rows that are for the DC metro area. And we still have the 246 columns, of course. Let's check out the very first one, in fact, Woodbridge. Let's check it out. So I'm going to put in check the first row of DC data. So DC Metro df.iloc. Remember, iloc is integer location. And I'm going to do 0, and 0, comma, and then colon. Remember, the 0 is the 0th row, first row, I suppose. 0th row, and then the colon means all the columns for it. So there we are. So there is the Woodbridge area, and you can see all the columns showed up. All right. What I want to do now is to change that region name to zip code, because it kind of bothers me that they called it region name. So let's change the region name to zip code. And we know how to do this. I'm going to do this just for the DC Metro data frame. I'm going to set it equal to DC Metro data frame and call the rename. And remember, with rename, you can rename columns, as many of them as you like. And this is the format. It's sort of like a dictionary. So columns equals open, close, curly braces. And then you simply list the column that you have right now, in this case, region name, and what you want it to be name to. So colon zip code. If I had additional columns, I could simply put a comma and repeat this, and it would replace or rename all those columns. Now that I have that, I'll just double check that this was done by looking at the first 5 using head, and I can see that the region name was in fact changed to zip code, which is great. I am curious as to what is the data type of zip code. So what is the zip code data type? You may recall that we can use the D-type property to get that. So DC, Metro, DF, and I'm interested in zip code, and I want to call D-type. And this tells me that it is being read in as a numerical value. It's an integer. I like it to be a string because zip codes are not used to add or multiply, etc. So let's convert zip code to string. And to do that, we just take DC, Metro, DF, and zip code. I am using a lot of tabs here. And this is going to be DC, Metro, DF, zip code, and we're going to call apply, the apply method, and apply a string to it. So basically that's converting it to a string. Having done that, if I take a look at DC Metro DF zip code now and call D-type, it comes up as O, meaning object, and strings are objects in Python, so I can see that in fact it's no longer numerical and it is an object, which is great. All right, I want to go over the concept of what a lambda is because we're going to be using lambda in this in the next step. But what the heck is a lambda? What is lambda? Lambda is Python's anonymous function. And if you're familiar with other languages and the idea of what an anonymous function is, JavaScript has it, Java has it, they all have it. It's a function that you don't give a name to. You create this structure which acts like a function, but it's only used once. It's a convenient way to basically put your code together that you need temporarily as one piece, but you never use it again. So let's go ahead and take a look at what is lambda. So it's Python's anonymous function. It does not get a name, though it can be assigned to a variable. All right, it is used in a single location and can be handy. This is a traditional function, so funcx, and let's say we return x squared. If I do shift enter, the function is created. I can say func9, and you can see it returns 81. Now if I want to do the same thing with lambda, let me have a variable name. I say lambda, here's my parameter, and you can have commas for them, and I'm going to return x squared. There you go. If I do G9 now, I get the same results back. So this is lambda. All right, so this is it for this video. This is going to be a multi-video presentation module for homes, but I'm trying to keep them, sizable so you don't get tired. Thank you for being a great audience. If you're enjoying these videos, please share them with loved ones and friends, and I'll see you in the next one.